Welcome back, guys. For today's video tutorial, I'm going to have a look over a sensor that is LSM330. To gain more knowledge about this sensor, let's have a look over the website, and that's controleverything.com, and have a search for this sensor and you can see more about this. So let's see what we got. So we got that LSM330 is iNEMO Inertial Module, 3D Accelerometer, 3D Gyroscope I2C Mini Module, and these are some of its features as you can notice on my screen. You can also purchase this sensor from this very site. Furthermore, I will be interfacing the sensor LSM330 with a Raspberry Pi, and for that I require a Java code. So let's go to resource tab, and here's the Java code sample we are looking forward, and you can download the Java code as a zip file from here. You can also have the Java code from the GitHub repository, that is Control Everything Community. Now you can download, and you can have two ways, either you can follow. Now we require some hardware so that we can put it together and make some connections to make our work of a sensor. So let's proceed. This here is our sensor LSM330, which we are going to be setting up today. In addition to this, we need a Raspberry Pi. Now, to provide the solution of connections among the sensor and the Pi, and to further make this connection a lot easier, and also to make connections with the other I2C devices, we need this I2C adapter or shield. This is available on the website controleverything.com. Now make this connection and gently place the I2C shield over the GPIO pins of the Raspberry Pi. Now, to make a connection among the sensor and the shield, the binding factor is this, a connecting cable. Now make the connection among the sensor and the cable like this, and make sure that the brown wire of the cable should be connected to the ground terminal of the sensor, and similarly we have to follow this fundamental rule for the I2C shield. So the connection will look like this. Now we need to power up our Raspberry Pi, and for that a micro USB cable comes into the picture. Gently put it over the power jack. Now we need to connect the Raspberry Pi with the internet. Now we have two options. The first is an Ethernet cable, which you are able to see on my screen. Gently put it over the Ethernet jack. In case if you don't have the cable, Ethernet cable, you can also use adapter, iNEMO, Wi-Fi USB adapter, and you can put it on the USB jack. So, hence we are done with the connections. These are the connections we require for the working of this particular sensor. Now why don't we have a look over the code, the explanation and the working, so that we can interface this. Well, as we are done with the hardware connections for this particular video, why not we have a look over the Java code. For that we have to interface the sensor. So first of all, go to github.com and here search for the community, for the repository, that is Control Everything Community. Now here, this is our sensor we are looking forward to check, LSM330, and this is the Java code. So why not we have a look over the instructions for this sensor first. We have downloaded and installed Pi4j library on the Raspberry Pi, and the steps to install Pi4j are provided on this very link. Let's have a look over this link for better clarifications. Now as you can see, all the relevant information, the commands and the instructions are being provided here for the offline, online, any manual or instructions provided here, so you can get through it carefully. Now you have to install this particular library so that we can have the code functioning alright. So this is the command to compile the code, and this is to run the code. Please note it down. Now get back to the code, and it's a Java code. As you can see, it's a .java extension file. The first thing you notice in the code that we have imported some of the libraries, and we will use the functionalities in these libraries later on this code, and we have created a public class named LSM330. Now the address of the sensor is dual, right? It's one for is gyro, one for accelo, so the address for the gyrometer is 0x6A, right? In that case, we have selected the control register 1 having the command XY and Z axis enabled, power on mode, output data rate equal to 95 Hz, and the command to write here is this. Now after that, we have to read 6 bytes of data for gyroscope, and here we come. the values are being stored, and after that we have the conversion part of this data, as you can notice, and it's all according to the data sheet for LSM330. Well, as we are done with the gyroscopic methods, now the turn comes for the accelerometer. The accelerometer address is 0x1D, as you can see on my screen, and here in the writing section we have selected control register 1, and the command we have sent is XYZ axis enabled power on mode output data rate equal to 100, and that goes for 0x67, as you can see. Now after that reading part comes, and we have read 6 bytes of acceleration data from address 0x28, as you can notice on my screen. Now the values are being stored, and after the calculation we have the conversion part of this data, acceleration data for X, Y and Z axis. As we are done with the calculations part, at the very end of our code we have to print out the data and to the screen, and we have the rotation in X, Y and Z axis along with acceleration in X, Y and Z axis, and we have the right format. In the raw value it's a percentage D, which means normal value of integer, it's a raw value. So as you see, it's a very simple and generalized code, a Java code for the sensor LSM330. Now why don't we have a look over the working so that we can have a better clarification, and that's the interesting part of this video. Now for the working of this Java code, first of all we have to copy this entire Java code and open up the terminal for the Raspberry Pi. Here create a new file, lsm330.java, which is the extension, and the code is, as you can see, paste the code and save it. Now this is the command for the compilation of the code, and the code is being compiled. It might take a while for the compilation, and we can wait for that. The code is being compiled. Now this is the command to run the code, as you can notice, and we have the values for X, Y, Z axis for the rotation and the acceleration. And again, now when I rotate the sensor, as you can see, there will be a change for the rotational and accelerational values for X, Y and Z axis. Now when I again do that, there will be again changes, and we can have several times the rotation, and all the time there is a change in all the values. So raw values, as you can see, for the rotational XYZ and accelerational XYZ axis. So this is how a Java code works for this sensor LSM330. So why don't we have a look over the sensors, features, benefits and applications, and to know it more better, let's proceed. So just now we have seen the working of this sensor LSM330. So let's have a look over the benefits, features and the applications for this particular sensor. As you can see, the LSM330 is a system in package featuring a 3D digital accelerometer with 2 embedded state machines that can be programmed to implement autonomous applications and a 3D digital gyroscope. The various sensing elements are manufactured using specialized micro machining processes, with the IC interface are developed using CMOS technology. Now the LSM330 has a user selectable full acceleration range and an angular range of good 250, 500, 200,000 dps plus minus. The accelerometer and gyroscope sensors can be either activated or separately put in power down sleep mode for applications optimized for power saving, and these include GPIS navigation systems, impact recognition and logging, gaming and virtual reality input devices, intelligent power saving for handheld devices, and a lot more. This sensor is available on this very site, and you can purchase it from here, and the relevant code is available on this very site. You go to resource tab and you can get it down there. Now you can also get the code from GitHub repository, that is Control Everything community. So at the very end, let's summarize what we have done this video. We have the explanation, the code, the hardware connections and a lot more stuff. So I just want to make it clear that in case if you are in a kind of thought that you are left without fully understanding any part in this video till now, you can have your queries on controleverything.com, and you can post your comments, your queries also on the community page. Now, if you want to check some articles, blogs relevant to this video, you can have a look over instructables.com. And if you want to subscribe video tutorials like these, you can go to our YouTube channel. I hope you found this video useful, and I have a lot more projects coming on my way on the YouTube channel also. So till then, you enjoy yourself, and thanks for watching.